Okay, so I have a little video. So you guys know what Star Wars is, right? I figured like no one knows. All right. What is this Star Wars thing? I want to show you guys how to set up a SFML project that does this. So we haven't really done text so far in SFML, and I thought that it might be nice to go through a couple of examples of how to use text. And one of them is to show you guys just how to use fonts and how to actually show text in SFML. Another one is how you actually can incorporate that into your game. So specifically in Pong, you should keep track of score. And in a lot of games that you're making, you want some kind of text in your game, whether for health or inventory or for a menu system or player names, all those things. And so having this, being able to show you guys this is something that I want to do today. Okay. So I have a week 8 SDVA engine folder that I want you guys all to grab because it has a font in it.
And we all won't be able to get it.
Yeah, if you guys can copy it. I just don't understand.
Damn it, I was at first. Do this
Clickaholics! You're all clickaholics!
Do it, Paul. Click on each one. Just try again. I don't understand why this like started happening. This is never. And like when you try again, it just lets you copy it. So just don't hit skip. Skip would be bad.
I just copied the Audion fonts into my old engine. So I don't have to copy the entire thing.
Yay. You want us to grab the solution?
Yep.
Brown fox jumps the lazy dog. The quick brown fox jumps over the lazy dog. 1, 2, 3, 4, 5.
Oh yeah. One other thing too. This project won't actually run. That's right. There's one other thing I need to give you guys.
What, you're giving us more stuff?
Yes, I'm giving you more stuff.
Why do you hate us?
There's a DLL file. If you guys try to run it right now, can you guys tell me if anyone can get it to run? Because I'm pretty sure there's a problem with it.
Yeah, I crashed my Visual Studio. Wait. Looks like it's running fine. Graphics is so good. Yeah, it didn't load properly.
All right.
Yeah.
Okay. Can I give you guys? I'm going to give you guys one thing, which will. I want you guys to replace. There's a file called engine-copy in there. I want you guys to start with that, and then replace the engine CPP file that's in the solution with engine copy. So like take that guy, and what I want you to do is go into the solution here, and remove engine CPP for now, and replace it with engine copy. So you can right click on it. So yeah, right click on the engine CPP and then do add existing item. Right click on this guy, and exclude from project. And then right click on source files here. Just down with that, and then try running it. And add existing item. You guys have a green circle here.
Exclude the engine from the project and put in the engine copy into the source file.
Put the engine copy in there because that is running. I want to start from scratch anyway, so.
You right click over on the source file. However, I can't get it back in. I saved this.
Open the solution file.
Right click on source files and say add existing item.
Oh.
Can you do that too, Frank? Yes, you guys are good to go.
I believe in the circle.
Okay.
The circle is life.
So, thank you for doing that because we got to get through the audio and sound effects part. So, kind of like what I want you guys to do in just a little bit is I want you guys to find a font. I don't know how many of you guys ever look for fonts, but there's like hundreds of them that you can look for. I have one in the project already that you can use if you want to. It's actually in the fonts folder. Looks like that. So I kind of want to explain a little bit about how fonts work in SFML first. So fonts are actually pretty straightforward. SFML treats fonts a lot like how textures work. So in order to get text to draw on screen, you need two pieces of information. One, you need the actual location of the file, and the other is like how you want to draw that file. Okay? The font itself contains within it information about how to draw it in different typeface sizes, as well as what it looks like when it's bolded or italicized and what characters it actually supports. So that file, you can load that file in SFML just like how you load a texture. And so when you want to draw it onto the screen, you basically take that font and you assign it to a text object. So there's something called an SF::, font object that works a lot like a texture. This thing has a load from file just like a texture. So you can have your if statement that says, I'm calling it fonts. The extension here is a TTF file. I believe that's what the extension is.
Right click on it.
Yeah, TTF file. So the file exists in this directory. Once you have loaded the file, if it loads correctly, you can continue. I have this if statement here that says if the font did not load correctly, then return 1. The other object you need to draw fonts are something called a text object. And this is akin to a sprite. So while fonts are more like a texture, text objects are more like sprites. So a font represents the file on disk, while a text represents what you want to draw. So text has a very similar interface to sprites. You call set font on the text. Once you have this, you have to actually tell it what kind of text you want it to show. So I'm going to do my text dot set string, and you can type in kind of whatever you want to. I don't know. I just wrote down the first thing that came to my head. You don't have to copy this. You can say Overwatch. Whatever you want. And then when you draw this object, you just draw it like you would a shape. So you're making sure you have a line for drawing this text. Text objects have all kinds of properties on them, just like shapes do, just like sprites do. You can set the size and rotation of them. So if I want to rotate this thing, I could rotate it 90 degrees if I wanted to. You have your choice. It actually rotated off. Let me do 45 degrees. Rotate it off the edge of the screen. You can also control the position of these this text object. They're calling set position. So there's my text, which is rotated 45. You can also move it if you want to, calling set position here. It's the same interface as you normally would for a sprite.
So the origin point is at the corner, right?
Yeah, you've got origins in the top left corner. And you can adjust the origin as well. You can adjust the position of this guy to match where the mouse cursor is too. And it just acts like a regular shape. So it's not really anything different from a regular shape. It just is an object. It just happens to be a string instead of a texture that you're assigning to it. Okay? You can also, there are a few unique functions to these text objects. You can set the character size. Character size indicates the how big or small this object is. And you can, it says the default size is 30, so you can shrink it down if you want to, or you can make it grow as well. This thing basically indicates how big you want it to be. You set this at the text level, like so. Okay. All right. Any questions on that so far? Pretty straightforward stuff, right? Okay. Okay. So what I'm actually going to have you guys do is, let's see, I want you guys to do, I have this lab file that I didn't share with you yet. So I have this this string, which is also the original Star Wars text that I want you guys to do. So let me go over the lab real quick. It's just a quick exercise and just getting some practice on it. So I want you guys to find a font that you like. There's this web page called DA Font that I use most often for any kind of game. Pick any kind of font you want. All these fonts will work in SFML as long as they're a true type font or open type font. Pick any of these fonts for representing this lab. And what I really just want you to do is draw the text "Hello World," and I mixed in a little bit of this rotation lab 2, I want you to make it so that when you're pressing left or right on the keyboard, it rotates this text by 360 degrees per second, exactly. Which means it'll take 1 full second to rotate the text around 360 degrees. So then what I want you to do is take the intro. So in the engine CPP, the one I had you guys remove, I have a string. You can also just copy it from here, where I want you to have this thing draw, and I want to scroll slowly upwards, and I want to draw in yellow with a character size of 30, just to look like kind of like the movie intro. If you can find the original Star Wars font, that's extra. But I just want this thing to draw from the bottom of the screen up. And then I want you to draw an FPS counter in the upper left corner. Okay? So before you get to this lab here, I want to go over how to actually draw, convert numbers into text. Okay? So let's do that next. So I have my string here. I'm just going to say Bastion. So how do I actually have this thing draw a number? Like, let's say I just have a counter that's going up, that's counting up from 0 to 100. How do I have that thing be printed out on screen? Like, I can't actually do, like, if I have a variable for my counter, I'm going to have this thing start at 0, and I'm literally just going to say my counter plus plus, so I'm going to add 1 to it every frame, or counter plus plus. How do I get that number into here? Like, if I want to set string on my text object, I can't actually just set a value of a number inside here. I can put the number 412 in here, which works fine, but how do I get some like actual integer value into a string? Well, you have to convert this integer value into a string. Okay? There are several ways to do this. So there's the C way, which is the original way before, like C++, and then there's the C++ method, which is a lot more kind of robust. So what I kind of want you guys to see is how we do it the C++ way, because it's kind of more foolproof, and then I'll show you one way you can do it to convert a number to a string otherwise. So I have my counter, and every time we've wanted to print out a number to the screen, we've always used something like cout, and it said my counter is counter, right? Cout, you guys understand how that works. Have you guys ever wondered what this thing was? What cout actually is?
Cout.
What is cout? What is this thing? You guys just use it, right? And you can see on the left here, it's printing out the cout object.
The console.
It's printing out to the console because it's the standard console out. But this thing actually that you're doing, this right here is not a command to do. What you're actually doing is you're stuffing this string and this value and this end line into an object called cout. This right here is actually a variable that you're pumping into. So the arrows here indicate that you're shoving data into that variable cout. Well, it turns out that there are other types of objects other than a console that you can stuff this data into. One of these objects is called an output string stream. String stream is a object that takes a series of characters and converts it into an object you can interact with to get the string out of or push information into, and it'll convert it to a string. So when we normally print out this, my counter is this, instead of typing it into cout, what we can do is we can make an object that represents, we can make an object that represents a stream of characters instead, and not print it out to the console. So there's a header you can include called sstream. Instead of iostream, it's sstream for string stream. Whereas iostream lets you write stuff to the console and also read things from the console. This represents that you want to write things to a stream of string. And we can use that here. So instead of sdcout, what I can do is I can make a os stream. string string. This guy right here is a variable type that we're going to write out to. So I'm going to say, what should I call this? And instead of writing to cout, I'm just going to do that. I'm going to print this to my, my string stream here. Okay? So I created an object of this type, which represents all the characters I want to shove to it. And instead of printing it out to cout, like this, I could do both actually. I could have one here, like so. I'm going to take it and put it into my object here instead. The reason why this is neat is now what it's done is taken my whole string, which includes numbers and everything, and shoved it into this variable I created. And then what I can do is I can ask that variable for a string in return. So I can say call my text, I can set a string. And what the string I'm going to set to is that object, and that object has a function you can call called str that says just get me all the characters that you represent as a string. And this is something you can pass to SFML, and you can call set string on. And this is this pattern here that I'm using is basically how you get it to represent a number. So you can see here now, my string on the screen is the same as my string on the console, right? And it's actually printing out a number. So this is how you do score. This is how you would represent score in like a game of Pong. This is how you would do like health, all those things. You would want to be converting it from a value into a string. Okay? All right, any questions on that? Let me put this up on Zool so you guys can have it too if you want it as a reference.
Do you also need to include IOStream?
You don't need IOStream in this case because if I got rid of this, I wouldn't need it. Like, you only need IOStream if you're going to actually use cout, which we don't actually need to use cout at all here. Like, cout is only for the console. You don't actually have to print it to the console at all. You can actually just print it out to the object. So now my console is empty, but I'm still able to get that variable here. So this pattern right here is what I want you guys to do to solve the lab number 5 and 6. So what I want you to do is make what's called a simple FPS counter. So an FPS counter is literally just 1 divided by delta time. That tells you how many frames per second you're getting. And then for lab number 6, I just want you to write underneath your mouse pointer, I want you to write the X and Y position of the mouse. Okay?